We are always talking about how human behavior is a big challenge, our cognitive biases and so on, for bringing about behavioral change in having to accomplish reduced consumption, decarbonization, sustainable development, and so on. And here is a different way of thinking about just how good our brain is. Despite all the limitations, our brain design is fairly complex and amazing, and this holds even for the brains of many other species, especially since AI is now telling us that many species are communicating with each other, calling each other by names: dolphins, elephants, whales, and so on. And here is an article that kind of is interesting because it talks about what cities can learn from the brain. So here is a schematic showing the outline of a brain, and then it's talking about all the urban design issues: transportation, buildings, mixed neighborhoods, and renewable energy, playgrounds, well-being spaces, green spaces, and so on, and what can be a positive impact on urban design and well-being versus what can be negative, given its ability to manage. I'm getting a mosquito bite, give me a second. Given its ability to manage a multitude of functions in support of survival, the dynamics and organization of the brain offer the city another confluence of structures and processes, lessons for urban design. So the brain offers lessons for urban design. I propose the concept of neuromimicry as a way of exploring the potential application of these lessons. There is already biomimicry, bio-inspired designs, nature-based designs, which are used or proposed at least in many contexts. So neuromimicry is more about how neurons and the brain communicates and coordinates all these complex tasks. In 1956, physicist J. Robert Oppenheimer gave a lecture to the American Psychological Association entitled Analogy in Science, in which he spoke to the value of turning to other systems or disciplines to advance science. During my PhD in cognitive neuroscience, which focused on the psychological effect of urban design, I developed an appreciation for viewing the brain as an analogy for other complex systems, such as the city. The city and the brain constitute a set of structures with parallels in both relationship and interconnection. Recognizing the scientific value in exploring these parallels for practical applications, in this comment I propose the concept of neuromimicry and explore similarities between the city and the brain. Okay. It's a simple essay, but very nice. I liked it, so I'm just summarizing it here. I also discuss concrete ways in which the former can learn from the latter for improved societal functioning and enhanced quality of life for urban residents. So you have quality of life things here and just functioning things here. What is neuromimicry and what is the value of analogy? Neuromimicry uses the brain as inspiration for the design of complex systems by invoking its structure and processes. Here the modern city is given as a use case for neuromimicry. It's an extension of the concept of biomimicry, a design approach that is directly informed by nature's blueprints. Although the practice of learning from the natural world have been in place for millennia in cultures around the world, the term biomimicry was popularized by American science writer Nancy Benyus in 1997 in her eponymous book, which means the book by the same name. The related concept of biomimetics was proposed in the 1950s by biophysicist Otto Schmidt, whose graduate research in biophysics focused on learning about circuit design through observation of nerve cells. He put this knowledge into practice in his creation of the Schmidt trigger, an innovation in electronics that was directly inspired by the nervous system of a squid. So it's not just human brain, right? Most recently, the emergence of neuromorphic engineering has demonstrated the value in using the structure and function of the human brain as inspiration for developing energy efficient computational hardware and algorithms. Clearly, there is precedent for drawing inspiration for design from intelligent systems found in natural contexts. So things, species like squids give you a very good analogy for minimal neural structures that do so much. So let me see if I can catch this bird. There's a little bird here sitting and feeling curious about what I'm doing, and he's looking and he sees me but doesn't seem to be bothered. Sometimes he knocks on the window, sometimes he just looks and then leaves. So I will include this video at the end just so that you can get some kick out of it. So it's a babbler. Usually they're in a group, but this guy always comes alone. Anyway, okay. One lens through which to examine the parallels between the brain and the city is complexity science, which recognizes complex systems that cannot be understood using traditional linear methodologies. Recent research suggests that the brain exists at the edge of chaos, which means that it operates non-linearly at the critical point at which order and disorder meet. As far as can be established, so I read the parenthesis which screws it up, but recent research suggests that the brain exists at the edge of chaos as far as can be established using empirical methods of observations. If you live in or have visited a large city, you may appreciate the relevance of the descriptors of chaos and disorder to urban environment. So the babbler ran away. So if we consider, let me close. If we consider the brain as a good model for the city on the premise of complexity science, I've discussed complexity a lot in sustainability science lectures I'm posting, where Earth system, human environmental systems are all complex, and yet there is self-organization, which means you can get predictability. So brain is complex, urban design is complex, but what can we learn by looking at how life has evolved to, fit so many things into a compact brain, especially when it's working properly, even for a squid or even a mosquito that has just few neurons, and it can manage to do so many things, right? So if we consider the brain as a good model for the city on the premise of complexity science, the question arises of where to begin. Carl Friston, in his highly influential explanatory model of the brain, the free energy principle, focused on prediction, the surrounding environment, and homeostasis. Can homeostasis be a goal for a city, and what would this look like? Homeostasis, in a simple way, is just maintaining some kind of a auto-regulation so that you have negative feedbacks and the system can remain stable. We talk about this also in the context of the Gaia hypothesis, where life is argued to have evolved to control the environment to make it suitable for itself. James Lovelock, which doesn't really work, but it's still it's a very interesting concept. Okay, given the fractured cities of our time, in which resource optimization is necessary and social disparities widen, I suggest there is a value in urban designers learning from a nervous system focused on collective survival. I'm not advocating for brain-shaped cities, but urban morphologies that draw on the organizational and dynamical principles of the central nervous system itself is what is argued in neuromimicry here. Communication, movement, resource allocation, and so much more is achieved by cells and electrical conduction, so signals going back and forth. What if people were cells and the corpus callosum border and lobes neighborhoods? So we are talking about brain parts. Or networks of brain communication were seen as transit maps, smart city data layers, or actual electrical transport. According to Bullmore and Sporns, the ascendancy of network science has been driven by the growing realization that the behavior of complex systems, be they societies, cells, or brains, is shaped by interactions among their constituent elements, which we talked a lot about in the sustainability science, about how a system is made up of elements and their dependencies and feedbacks, right? Network effects and optimization of optimized transportation as an example then. Cities involve the transportation of people. Mode share refers to the percentage split of commuters, including drivers, cyclists, transit users, and mobility device users, and those on foot. These indicators can be used to evaluate the outcome of transportation infrastructure decisions, which tend to be divisive and political because people don't want the highway in their backyard, metro in their neighborhood, and so on. This can often be seen in the comment section of media articles, online fora, social media posts, and so on. Often, at least in North America, a city will announce the building of a protected bicycle lane that travels down a few city blocks but is not connected to a functional grid that considers navigation in an entire city. So the last mile problems are not used. Just a piece of safe bicycle lane in the middle of nowhere doesn't help much. This makes the short experience of bicycle lane pleasant but useless for its intended purpose of keeping people safe for the entirety of their journey or getting them out of their car onto the bicycle. The dynamic of low use can serve to entrench a negative feedback loop of the public discourse on the value of bicycle lanes, and consequently hesitation on the part of politicians and decision makers to stand behind the active investment in the transportation infrastructure. So unless it's usable and complete, it will not be used. Then people will say, why waste money on that? This works for metros as well, where metros need to reach a certain critical level of possibilities in terms of getting around without a car before people can actually say, I can live without a car. And it happens in a few cities, but mostly not possible. The more connected a network, the more nodes and intersections, the better the experience of the infrastructure, which is then reflected in an increase in its use. So if this is a phenomena known as network effects, which is what I meant when I say a metro network that is complete can actually help lots of people increase traffic, increase revenues, and then becomes easier to maintain and grow as well. Describing the application of network science to understand the brain, Telesford and colleagues emphasize the utility of graph theory in that systems can be viewed as a graph in which nodes are connected through edges or links. Graph metrics include centrality and community structure, terms and concepts that are also used in urban planning and street network design. The network approach to the brain considers not only areas of activation but also the strength of connection between them. Proximity has benefits for both the brain and urban design, but resources need to be shared so that infrastructure of energy allocation can maximize efficiency. The general lesson for the city is that whether applied to bus routes or bicycle lanes, there is value in thinking of the core areas of the city as nodes whose access can be optimized by the urban system according to network science principles. Better connection yields greater use, obviously, and that leads to better funding and easier to sustain, maintain, and grow. Consequently, the demand justifies improved investments by different levels of government and accordingly less reliance on private automobile use, which stands to have considerable positive benefits on cities, including decreased air pollution and liberating road and parking space to be used for more critical needs such as housing or playgrounds, safe areas without traffic so people can walk around, and so on. On smaller scale, in recent years, the concept of the 15-minute city, in which basic amenities such as grocery stores, childcare are accessible within minimal travel time, has prompted conversations on the value of human scale, proximity, and connection to resources that enhance quality of life. So co-benefits in terms of quality of life and well-being are tremendous, and often their benefits are not included in cost-benefit analysis, right? Self-organization and local neighborhoods of function, localization and functional specialization are also important qualities of the brain. Legion studies have taught us that specific parts of the brain can have specialized functions, such as vision or language, and demonstrate the necessity of connections between a brain region and a particular cognitive process, not just their mere association. The brain leverages both wide-ranging network of tracks and specialization of functions. This raises the question of what this might look like in a city. Perhaps the creation of dedicated areas such as innovation, brewery, art, industrial districts, and so on. Consolidation of resources would be more cost effective, and a concentration of human potential could benefit connections and collaboration, thus strengthen specific areas of the city as demonstrated by increased density and relatedly more efficient use of resources, whether they be land, social capital, or energy. Strengthening nodes in cities has the potential to draw more people towards them out of necessity or interest, which would potentially prompt investment into their teleconnectivity through transit or active transportation infrastructure, as mentioned in network effects and optimized transportation. At the same time, I believe that we are in the post-zoning era, and we should challenge conventional approaches to urban planning, which are harmfully rigid and strict in the determination of land use, that is, a space that is designated as only commercial or residential, and then hard to retrofit them or change them. Self-organization in urban planning context is considered to be a complex systems bottom-up approach to land use allocation that is citizen-driven and is less fixed and deterministic. That's if you do self-organization from the beginning to plan. It has been proposed to involve self-building, self-governance, and self-coordination. Returning to the notion of citizens of cities as cells of the brain offers practicalities and potentialities relevant to urban design and governance, particularly as it pertains to the fluidity of the urban built environment. Self-organization is also a principle of complex systems and quality of the human brain, and is suggested to have 7 distinct properties. What are the distinct properties of this complex system? Modular connectivity, unsupervised learning, adaptive ability, functional resiliency, functional plasticity, and from local to global functional organization, as well as dynamic system growth. Okay, so all these are important. Modularity makes interdependencies less rigid, so that if there is a flooding in one region, you have alternate routes. If transportation breaks down, you have alternate ways of getting home. So resiliency builds in along with these flexible designs, which are arising out of self-organization. Modular connectivity and functional organization have been discussed. The property of unsupervised learning aligns with the self-determination of residents in shaping their environments to facilitate dynamic urban growth. So unsupervised learning is very common in the machine learning language, and I have podcasts on that elsewhere if you want to follow up. Furthermore, a fascinating implication of recognizing resiliency as an inherent characteristic of both brains and cities is that the two support each other. So plasticity is also studied a lot, where if one part of the brain gets damaged, then some other part can take over that function to some extent. So furthermore, a fascinating implication of recognizing resiliency as an inherent characteristic of both brains and cities is that the two support each other. Urban design that allows for responsive, adaptive, and dynamic growth has the potential to facilitate the same for our brain. As research continues to emerge about how our cities affect brain health and neuroplasticity, the ability to apply the findings practically is paramount to public health and contingent on flexible policy, open-minded politics, and citizen engagement. Okay. Finally, how can we build a city that needs its people, a city that meets the needs of its people? These are concrete examples of what neuroplasticity may look like in the urban realm, but its fundamental nature is that it is responsive to the needs. So needs may evolve with, let's say, climate change or population growth or economic social changes and so on. Likewise, a responsive city can use the principles of neuromimicry to inform urban design decisions that ensure a healthy city. For example, traffic calming a busy road affects For example, traffic calming a busy road. I don't know why it's called traffic calming. A busy road affects the cognitive development and respiratory health of children living nearby. So you take a busy road and you do traffic calming, which means you somehow find ways to avoid the traffic jams, emissions, honking, and all kind of crazy road rage issues, which have co-benefits on cognitive development and respiratory health of children living nearby. A responsive city is also one that responds to its open wounds, such as areas of disinvestment or disarray, often due to historically systemic oppressions, which means a slum area may not get new shops or hospitals, may instead get wastewater treatment plants and power plants and so on. The brain attends to healing indiscriminately, a collectivist approach to survival and a potential ideal and aspiration for cities. So you don't think of protecting just your neighborhood, but you think everybody is in this together. Another fundamental principle of the brain is that of learning from feedback and correcting past mistakes, a quality that could be embodied more by cities. Innovation lies in the capacity for meaningful iteration. The current emphasis is on car-centric urban planning, and repeated infrastructure investment mistakes arising out of that, and those are clear example of contrast between how the brain operates and how cities are managed. So brain is managing tremendous traffic flow of information, audiovisual cues, your need to manage things like looking at the bird while recording a podcast, or picking a cup of water and drinking it because you're feeling thirsty as you're speaking, and so on and so forth. Instead, they should learn from what research shows about the dangerous consequences of car centrism, the health and societal benefits of alternate modes of transportation, and the value of human-focused urban design as opposed to just focusing on economics. There are many layers to understanding the implications of lessons from the brain to the city. Neuromimicry points to how we can intentionally design evidence-informed, thriving cities in a rapidly urbanizing world to support planetary health. So it's a bit of a jump. Planetary health is where we worry about not just ourselves, but ecosystems, biodiversity, health of other species, and so on as well. Okay, so I thought it's a cute little idea, neuromimicry, so I wanted to include it, and hopefully you find it useful as well. And there are some good papers cited that you can follow up with, including the author's research work. Okay, I'm going to add the clip of that babbler that I mentioned during the podcast, so just watch out for it. Okay.